with what Jioni safu nola with whatever we do. Haleyi demunyu skula nyepamne ne kudlukula nyepangiragala gena nyepamne ne kudlukula ibuloke nongoto ni beti sola ibuloke dato ni betoto
Mingi Congo
Lamin
na
Lami te jibe norin te nyamen Lamin
kabana wuloko
wuloko no nyinta mo Lamin
pabilenki
muna ngata afongole
haina
ngata ngoto le Fabrama
Mingi baba nyole
ngoto le Fabrama
namu jumala kan kuma diten
Fabrama
jumala mu
ndele bare muso
lunda mana
famo kata
jamani mbere
alindo ko
jamani
bari ngoto man kontande
bari jamani fana na rabudu ma kontan
ngoto minaka ngalamin de fom filitala lamin jibe nori nyaala
lamin ile siran sama ne benki yala so tol sayni no ko mo lokko momo
ngoto
nam
iterinte yalo ne lamin hakilo diata bake karambu ngoto anu santeng ministry ko di ngole si suko na amake ko do holiday
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko ina karta bulo be damna ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu nekata
ifika lamin ki wulo ko no nyintai mon ko do fete malo lamin nyanta sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko nako
karambu wol ma soron ni ko karambu wol soron da amake ko holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adan dal kombo len do la jankara mol le soron do kamen courant ma daro lo kombo e to ndol fana na kara mol soron je kara mol soron lamin adara lo nyino la amanta la fena sokon ala munekela
am lamin ide foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyina di mod lamin ya muna fonye
bir kabin mina kan tambita nteri maning Fatu
ha
tambide la suko ala diningol bebe siri be la moyka
Fatu danso am fana tambida jele ni subala la ngaje diningol be jet talanta nen kili warol e be siri jelet
sa lamin fadante ku kili wo ke no la ba lamin bita ka wulo ko no nyin taymo alami
amandara fenela
ite dine ko ni man si yakari lesino la moy radio to e balon nan
muneka ke afonje ba nyaara ni be alon
telentel jikot
afonje ba mu de be ke
ite balon tel be jikiritel ni man karambe ku kele yaaje nata karana mbasa malaya ay taride
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko lamin manya tala wulo ko kara mo be so da fanya membe kala
ko to wole nati ba ngal le ni lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto da bungo bar radio be bulan koto batiri sanga ay
sa do kala nyaadi
ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ile subject do baby jele baby jele
wala nanga chocho moy fa dan so wolya ngombe tambi kana ngadi ningol je be ikadum bungo ko kala ma mo
asototal de
la min mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sini lamba nde le sini lo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat yu fana bulata ko ko me yen nati jambi lamin nyanta karana ntel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wala ga munda kara mo man soro lamin nyanta kara si suko na regular
silale ayala le sino
dal ko korno ko smolon
kilar ya
be ngala ko momo say mi do ni fano kera
mengi bruzo
ndelo ko do la da baro sa no radio ba bari woro radio ni abe je le baro ngamra do man nembe buljan dala nyara nyar wofram ko fendi mo la lamin tayra ba do sa
bara te ku folo ajibe nori nya labi tamete ku
mengi mun na re
teku
bari ko do famo ke
imagine nani nyambol si zol le keje kisiki man si zol no le kafunga nyoma bari nyambu kino ni manya na kafindi ni nambe ko do zol la ni nambe ko
ngale limbeta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
koto bari famo kada
ngata bun kono tammi bun kono nyara ngando ko fele ko kede baru nganda ni pelo la di jak
iyo awa betar la
bun kono bismillah bisu diara
ye fongo tanka sina dolu tanka koro Korota, hey, korota.
Hello, viewers and listeners. Welcome to another lesson on mathematics. And of course, this lesson is going to target people on the grade 4, 5, and 6. And today we are going to start a new theme in mathematics, which is algebra. On the algebra, we are going to discuss simple algebraic expressions, at which we'll concentrate more on adding like terms. So be rest assured that this lesson is going to be fun. As we said earlier, the topic on the discussion today is algebra, and algebra is a theme, it's too broad, so we are going to concentrate on adding like terms. In algebra, letters are often used to replace numbers. We'll come to realize how do we use letters to replace numbers shortly. Right now, I want us to look at this picture. If you look at it keenly, you can see some mangoes. What we have here is a mango plus another mango is equal to what? If I give you a mango and I give you another mango, that will be a mango plus a mango. What will that result to? Well, that is going to give us 2 mangoes. So if you look at the pictures, under each mango, there is something written there. Under the first mango, you have 1 mango, plus under the second mango, you have 1 mango. Simply, we are saying 1 mango plus 1 mango is equal to what? 2 mangoes. 1 mango plus 1 mango is equal to 2 mangoes. Now, remember previously we were looking at the pictures. Now we are looking at the mango as in its spelling. Now let's decide not to use this full spelling of mango, and we take only the first letter, which is M. So if you have 1M plus 1M is equal to what? 2M. Remember, the M here represents mango. So 1 mango plus 1 mango is equal to 2 mangoes. What this thing is simply telling us is that M can be used to represent mango. It's just like when I say 1 plus 1, it is equal to 2. 1 plus 1 is equal to 2. So here is 1M, that is 1 mango, plus 1 mango is equal to 2 mangoes. That is 1M plus 1M is equal to 2M. So we can use letters to represent numbers or to replace numbers in expressions. Similarly, we can have the same results for any letter. So being it A or B or C, we can always use letters to represent numbers in expressions. Like if you look at these other ones, what we have is A, just letter A. How many A's are here? There is only 1 A. So we can say A here is equal to 1 A. That is what we have here. Now, how about if we have 2 A's? This A here can mean an apple. How about if we have 2 now? You have A plus another A. What will that give you? How many A's do you have? Here is 1 A plus another A. So how many A's will that be? A plus A will give us what? A plus A will give us 2A. And that's what we have there. If you look at it, to add A and A together because they are the same. Don't worry, we'll come to talk more about those things. You can do it for having 3 A's. When we assume the A is an apple, or it can be anything, it can be a phone, iPhone, it can be any other phone. So long you take that A to represent something, and here if we assume that A represents apple, then Y's. How many Y's are we adding? We have 1, 2, 3, 4, 5. We are adding 5 Y. So the answer to Y plus Y plus Y plus Y plus Y is going to give us 5Y. So you can use any letters. You can use Z if you want. You can use Q and so on. But when you add them together, it's going to give you the number of those letters that you're adding. We'll talk about this more in the next slide. So let's move forward. In this slide, we're going to talk about terms and like terms. We're going to talk about terms and like terms. On the terms here, when we reflect back to the previous slide, we were talking about A plus A, and we said A plus A is equal to the discussion on the terms. What are? If you look at it in this context, we have A plus A is equal to 2A. In this equation, we have how many terms? We have 3 terms. A is a term of its own. The other A we are adding is a term of its own. And 2A is a term of its own. Why are they terms? How do we terms, expressions, or equations? Well, terms are created in an expression or equation when they are separated by either a positive sign or a negative sign or an equality sign. These are the 3 signs that separate terms in an expression or an equation. Right now, let's only talk about expressions. So along the lesson, you may be seeing addition and subtraction. More so, the lesson is about addition. We'll be seeing a lot of additions. So how do we identify terms? Is when we have an expression that is separated with the addition sign. So for instance, when I have 2A plus A, in this expression, how many terms are here? If you observe, we have 2A and A, but something is in the middle. What is in the middle is the addition sign. So we can conclude that there are 2 terms here. 2A is a term of its own, and positive A is a term of its own. So in this expression, I would like to bring something else. Let's say we are adding a lot of A's, like A plus A plus A plus A. Let's say this is the expression we are given. How many terms are in this expression? Looking at it keenly, we are adding 4 A's. What is in between these A's are addition signs. So each and every one of those A's is a term of its own. They are all positive. So similarly, we can have 2x plus y. What do we see? We have 2x plus y. We are talking about a's. So don't only think when the variables are the same is when terms are created. No. The variables can be different, yet we have terms. Now in this expression, 2x plus y, how many terms are there? Addition is in between 2x and y. So 2x is a term of its own, and positive y of its own. So in the expression 2x plus y, there are two terms. Terms also have like terms and unlike terms. Let's look at like terms, and then we'll build up as to what are unlike terms. The definition of like terms that we have on the board here reads, like terms are terms that have the same variable. Like terms are terms that have the same variable. Like for instance, we are given an example that is 3x and x are like terms. When you have and only x, these are like terms. 3x and x are like terms because the term 3x has a variable x, and the term x also has a variable x. So if you look at it, these two terms have something in common. And what do they have in common? They have the letter x in common. So that is why they are like terms. Let's look at other terms, and we will be able to identify what are the like terms. For instance, when I have the expression 2a plus 3b plus an a plus a b. Let's try to identify the like terms. If you can remember, we said terms are separated in an expression, in this case by the addition sign. I understand that. So we can say 2a is a term of its own, positive 3b is a term of its own, a is a term, b is a term of its own. So what are the like terms here? Following the definition, that like terms are terms that have the same variable. The variable, we are referring to the letters, the unknown. Those are the ones we are referring to as the variables. So let's look at the letters. We have 2a, 3b, that is 2a plus 3b plus a plus b. If you look at it, 2a is having the same variable with the term a. The term 2a is having the same variable with the term a. And what is the variable there? The variable is a. So we can say 2a and a are like terms. That is 2a plus a. Those ones are like terms. So we are able to add 2a and a together because they are like terms. We are able to add 2a and a together because they are like terms. And if you go further to simplify this, when you have two a's and you have another a, you put them together, how many a's will you have? Let's say this a represents someone whose name is Amadou. You have two people that bears the name Amadou right here. And you have another person who bears the name Amadou. And you add him up to the other two that they have. Now, how many people will you have that bear the name Amadou? The two that you have plus the one that you bring is going to give you how much? 1, 2, 3. It's going to be 3 of them. So the same idea is what we are trying to do here. we have two a's and we want to add another a to it. This is only possible because the variables are the same, because the two terms are like terms. So we can go forward to add this to be 2a plus a to give us 3a. But don't worry, we'll come to do more of that in the lesson. Let's try to spot out the other terms here. The other like terms in this expression. We've already spot out the like terms when the variable is a. So do we have other terms when the variable is b? The answer to that question is yes, because if you look at this expression, there is a term that is 3b and there is another term that is b. So the variable in 3b is b and the variable in the term b is b. So in that case, b and b are the same variables, so the two terms are like terms. So in this case also, we will be able to add 3b plus b. We will be able to add 3b plus b because they are like terms. Let's say the b represents banana. If you have 3 bananas plus a banana, how much will it give you? There you can add them, not so. You can add bananas to bananas. So 3 bananas rather, plus a banana will give us 4 bananas. That is going to give us 4b. So in our today's lesson, we are going to concentrate more on adding like terms. So we'll be given expressions that have different terms. What we are going to do is we are going to spot out all the like terms, put them together, then add them. That is going to be the lesson today. So let's move on to doing that. Now we look at these expressions. The instruction given to us is simplify the following expressions. And we have 2 of them here. The first one we have 3y plus y plus y. And the second one we have 6p plus 3p plus 2p. Let's start with the first one. 3y plus y plus y. First of all, let's try to examine whether they are like terms. Looking at the expression, how many terms are here? You have 1, 2, 3. 3y is a term of its own, plus y is a term of its own, and the other plus y is also a term of its own. So in the expression 3y plus y, there are 3 terms. Let's move on to see if they are like terms. We define like terms as terms that have the same variable. And we said the variable is the letter that we have in the term. In the 3 terms that we have here, that is 3y, y, and plus y, in every term, if you observe, you will see that there is a variable y. So we can conclude that all the terms in this expression are like terms. So we are asked to simplify, and the operation is addition. Let's go ahead and do that. I'm going to use somehow a long method of doing that, because I would like to split this 3y. 3y simply means y plus y plus y. Just like in the case of a plus a plus a, we said this is equal to 3a. Now instead of the question giving us a plus a plus a, we are given 3a. So what it simply means is a adding itself 3 times. So when we have 3y also, it means y adding up to itself 3 times. So only 3y will give us y plus y plus y. That is 3y. Then here we have plus y. That is the second term is plus y. Then the third term is also plus y. We have it down, we have plus y. So in total, how many are we adding? We have y plus y plus y plus y plus y. How many y's are we adding? 1, 2, 3, 4, 5. So when we add y 5 times, the answer is going to give us 5y. Well, this could have been done in another way, and shortly I will show you. Instead of opening this 3y into y plus y, we could just add the other y's. 3y plus y will give us 4y's. If you have 4y's and you add another y there, it will give us 5y's. So that gives us the answer, 5y. So later on in adding like terms, we may not be opening the 3y. Or if we are given 2y, we will not open it up to give us 2y's and then add the other y's. We just take 3 plus here is 1y. The reason why you're not seeing 1 there is because y is alone. So just y. You don't write 1 there. But if the number of y there is more than 1, the number will be given to you. That is why here, the number of y's that we have here is more than 1. There are 3 of them. That is why you have 3y. I hope that is clear. So 3y plus a y plus another y will give us 5y. Let's look at the second example. In the second example, we are given 6p plus 3p plus 2p. 6p plus 3p plus 2p. In this expression, how many terms do we have there? If you look at it, we have 3 terms. 6p is a term of its own, 3p is a term of its own, and 2p is a term of its own following the definition of a term. Again, we look at whether all the terms are like terms or which among them are like terms. Let's look at the variable. What variable do we have in the first term? The variable in the first term is p. Let's look at the second term, that is 3p. The variable in the second term is equally p. Then we look at the last one, that is the last term, 2p rather. The variable in the last term is also p. We said the variable is the letter that is used to replace the number. So here we have 6p plus p plus 2p. All the terms have a common variable. P is the variable and is common in all the terms. So this simply tells us that we can add them together. So in doing so, what we are going to do is we are going to add 6 plus 3 plus 2. That will give us the total number of p's that we have. 6p plus 3p will give us how many p's? If you have 6 p's and you add 3 p's to it, that's going to give us 7p, 8p, 9p. Then you add 2p on it again. So I'm going to do it step by step. I'll add 6p and 3p together. 6p plus 3p will give us 9p. Plus the one that we left behind was 2p. Let's break it down. 2p. So 9p plus 2p will give us 11p. So if we add 6p plus 3p plus 2p, our answer is going to give us 11p. Remember, the reason why I bring in this bracket is because I want us to confine ourselves into adding only 6p and 3p. But if you are comfortable adding all of them at a go, it is not a big deal. So you p plus 3p, which is going to give you 9p, then 9p plus 2p is going to give you 11p. But I would advise you, always when solving questions like this, you solve them step by step. Now we look at this other set of examples. Simplify the expressions below. The expressions that we have are 3a plus d plus 2c plus 2d. And the second example is 12b plus 3a plus 4b. Let's look at the first example, which is 3c plus d plus 2c plus 2d. In this expression, how many terms do we have here? We said or subtraction separate terms in an expression. So we have a lot of terms here by the addition sign. How many terms do we have? We have 1, 2, 3, 4. 3c is a term of its own. D is a term of its own. 2c is a term of its own. And 2d is a term of its own. Our objective in this case is to collect the like terms and add them together. So if you look at it, in order to spot out the like terms, we said they must have the same. The variables that we have in this expression, they are two. We have c as a variable and d as a variable. So all the terms that have the variable c, we are going to put them together. And all the terms that have the variable d, we are also going to put them together. So this is going to give us, the first term here is 3c, the second term is d, the third term is 2c rather, and the last term, or the fourth term, is 2d. So you can see the terms that have the variable c are 3c and 2c. So we can have those ones grouped together as 3c plus 2c. We are putting them together because they are like terms. Then we continue adding plus. Then we look at the other variable, that is d. If 3c and 2c are like terms, let's find out if d and 2d are also like terms. They will be like terms when they have the same variable. Well, as you can see, they have the same variable. D is a common variable in both terms. So it means d and 2d are like terms. So we're going to have, after having 3c plus 2c, we are going to have plus d plus 2d. As you can see, we've created another expression, but here we only arrange the like terms together. That is 3c and 2c are like terms, and d plus 2d are also like terms. Then we move ahead to adding the like terms. 3c plus 2c will give us 5c plus the other like terms are d and 2d. D plus 2d will give us what? If you have a d, add 2 d's to it, how many d's will you have? It's going to give us 3d. So when we add the first two like terms, that is 3c and 2c, you have 5c, and the other two like terms, that is d and 2d, when we add them together, we have 3d. Can we add 5c and 3d? The answer is no. Why? Because the two terms are unlike terms. The variables are different. The first term, which is 5c, has a variable of c, and the second term, which is 3d, has a variable of d. So here is where we can stop in terms of simplifying the expression. If you observe, when I add 3c and 2c, the answer is 5c. I wrote 5c instead of writing c5. Some of you may be thinking, why are we writing the numbers first? Well, that is how it should be done. You cannot write the variable first, then bring the number. You go to higher, this number has its own name. it will be given to you when the due time comes. Now, what I want you to understand is you cannot write the variable before the number. So just like any other example, you cannot write. The correct way to write that is to be. So always when you add like terms, you bring the number first, then you bring the variable. Let's move on to the second example. The second example reads 12b plus 3a plus 4b. In this expression, how many terms do we have there? We have 3 terms. 12b is a term of its own, 3a is a term of its own, and 4b is a term of its own. Our interest here is to simplify, to add the like terms. We know there are 3 terms. Let's go ahead to find out whether all the terms are like terms or 1 or 2 out of them are unlike terms. Let's look at the expression. 12b plus 3a plus 4b. How many variables do we have there? We have 2 variables. A is a variable and B is a variable. So we are going to look at terms that have one of the variable, and those terms will be referred to as the like terms there. The first term has a variable of b, that is 12b. The second term has a variable of a, that is 3a, and the third term has a variable of b, that is 4b. So in this case, you can see that 12b and 4b are like terms because they have the same variable. b is common in both terms. So we're going to put them together. So this is going to give us 12b plus 4b. What is the other term in the expression? The other term is plus 3a. Does 3a have any other like term here? No, because there is no other term that has the variable a except 3a. But b has a like term, that is 12b and 4b are like terms, so we can put them together. This is going to give us 12b plus 4b is equal to 16b. Like you have birds. You have 12 birds. And a friend of yours came and gave you 4 birds. Now in total, how many birds would you have? That is 12 plus 4 is going to give you 16. So when you add 12b, the answer is going to give us 16b. Then the other term there is 3a, that is plus 3a. We have 16b plus 3a. Can we add these 2 terms? No, we cannot add the 2 terms. Why? Because they have different variables. The first term, which is 16b, has a variable of b, and the second term, which is 3a, has a variable of a. So this is where we can stop in terms of simplifying this expression. So if we simplify the expression 12b plus 3a plus 4b, our answer is going to give us 16b plus 3a. That does it for that question. You move on. Here we have some questions that we want you to try. You try the questions at home, and when you come back in the next lesson, we are going to do the correction. I will read the questions out. The first one, we have 6x plus 2y plus 5x plus 3y. I repeat, 6x plus 2y plus 5x plus 3y. That is the first expression. What you are asked to do is to simplify it just like the way we are doing the other ones. Collect the like terms and add the like terms. Don't add the unlike terms because they have different variables. The second question in the try questions is 10d plus 7R plus D plus R. 10D plus 7R plus D plus R. So in this case also, identify how many terms you have, collect the like terms and add up the like terms. That is it for today's lesson. Thank you for listening, and we'll meet next time to continue on algebra in our subsequent lessons. So thank you.
Ibe nyim fengol lampi kan iban kaspa o jibe kaspa o fila banta ko do fila ida kaspa o sanna
ko to bar suwa ko tale ko patoro ngam Mamadou ko mandi ba hello Mamadou abijan dron ko tarande du ko rimbala yende manan kaspa wala say ha bantale hadi fentiji yo okay mabakuna abarka ba kayame
Maria ite Mamadou ba tarano bantala banko kan nyadi le ka kaspa o kini te jang say
ngodo fe malon ko balu ya kelo ko den ibe bantala banko kan dawo da